All right, hi everyone. Today we are going to continue factoring trinomials. So we're going to basically do exactly what we did in the previous video. However, we're going to look at some examples where there's a GCF involved. So we know what GCF means. It means greatest common factor. So we're going to take a look at trinomials that have a greatest common factor to take out. And then we still have an a greater than 1 situation. So this is kind of what we learned in the last video. So again, last time we factored trinomials where a was greater than 1. And all that means is this a is this first coefficient right here. So the number in front of the x squared term. If that number is anything bigger, anything except for 1, then we have to factor them a little bit differently. So we learned how to do that last time. Now today we're going to look at trinomials that have a greatest common factor to take out first. So let's go ahead and see, do we have a greatest common factor that we could take out of here? Can you think of a number that goes into all three of those? The number that would work would be 5, right? 5 goes into 10, 5 goes into 75, and 5 goes into 35. So let's go ahead and take out the 5. So we've done stuff similar to this before, right? We know how to take out a greatest common factor. So to take out the greatest common factor, you just divide everything by 5. So if I divide all of this by 5, well, the first term, 10 divided by 5 is 2, so I would have 2x squared left over. And then in the second term, 75 divided by 5 is 15, so plus 15x. And then 35 divided by 5 is 7, so plus 7. And then you have to take a look at what you have left. So we have this trinomial left over. And trinomials can still be factored most of the time, right? So if you have a trinomial left over, something that's in the format ax squared plus bx plus c, then you have to try to factor it. You can't just leave it like this. We have to try to continue to factor this out. So we're going to try to factor this trinomial the way that we learned last time. Now we still have a trinomial where a is greater than 1, which means we have to do what we did last time. And the way that I taught was this method where we multiply the first number by the last number. So 2 times 7 is 14. And then we list out all the factors of 14. So 1 times 14 or 2 times 7. And you pick the factors that would add up to that middle number, so that 15x. And the factors that would work would be 1 and 14. And we do need to make sure they're both positive. So then what we did was we split up this middle term. So we rewrote it. And instead of 15x, we're going to rewrite it as positive 1x and positive 14x. And then we just brought down the 7 and the 2x squared. And the next thing that we did was we factored this 4-term polynomial by grouping. So we're going to go ahead and group the first 2 terms together and the last 2 terms together. So then we need to figure out the greatest common factor, right? The greatest common factor here, what do they both have in common? Well, it looks like we can take out an x. So we're going to take out an x, and I would have 2x plus 1 left over. And then over here, I can't take out an x, but I can take out a 7 because 7 goes into both of these. So we're going to take out a positive 7. And then I would have, if you divide this by positive 7, you're going to have 2x left over. And then 7 divided by 7 is 1, so plus 1. And then we're almost done, right? We have our 2 factors. So our 2 factors would be 2x plus 1. And then the other one would just be this leftover part, this x plus 7. But keep in mind, we actually have one more factor that we kind of forgot about, and it's up here. It's this 5 on the outside. So you can't just get rid of that. I'm going to make sure I bring it down. So I'm going to bring the 5 all the way down and put it next to these parentheses here. And then this would be our final answer. This would be completely factored. So we've got the GCF on the outside, and then we've got our 2 factors in parentheses. So this is basically what we're doing today. We're just going to look at trinomials where we need to figure out this outside number. We need to figure out the greatest common factor. And then we have to factor the remaining trinomial after we're done with that. So let's look at a few more examples. And one thing I do want to point out, because as we go forward, we're eventually going to get to a section where we just give you some mixed problems, and sometimes there will be a greatest common factor and sometimes there won't be. So just make it a habit, start to make it a habit to always check for a greatest common factor first. No matter what it looks like, No matter what the directions tell you, this should always be your first step. And it's really easy to do. You just look at each of the terms and you try to figure out, is there something I can pull out? Is there something that they have in common? So just make that a habit. Always check for a greatest common factor. Okay, so let's continue. Let's take a look at these examples. So remember, first step, we're going to check for a greatest common factor. So is there anything that goes into 12, 2, and 2? And you should be able to figure that out. The greatest common factor there would be 2, right? 2 goes into all 3 of those. So we're going to go ahead and take out the greatest common factor. We're going to put it on the outside. And then we're going to see what we have left. If I divide all of these by 2, well, the first term would become 6x squared. The last 2 terms, we're just dividing 2 by 2, which means it's going to be 1, right? So this is going to be positive 1x, or you could just write it as positive x if you prefer, right? You don't have to have the 1 there. And then let's see, the negative 2, that's just going to become negative 1. So there we go. And now we are left with a trinomial, and a is still greater than 1, which means we have to do the method that we learned in the last video. So we're going to take the first number and multiply it by the last number. 6 times negative 1 is negative 6. And then we're going to list out the factors of 6. So 1 times 6, or 2 times 3. And we have to make sure that they add up to positive 1. So which factors would add up to positive 1? Well, it would be these two if you make the 2 negative and the 3 positive. So those are the numbers we're going to use. The 2 needs to be negative and the 3 needs to be positive. And then we split this up, right? We're going to split this up into negative 2x and positive 3x. And then we're just going to bring down everything else. So we're going to bring down this 6x squared. We're going to bring down this negative 1. This 2 on the outside, you might want to circle that or highlight it or something, because eventually we're going to have to bring this down too, right? So I don't like to bring it down just yet because I want to deal with this stuff first. But you do need to make sure you don't forget about that 2 on the outside. Okay, so the next step here is to factor this by grouping. So let's go ahead and do that. If I group those together, what would be the greatest common factor here? So let's see, it looks like 2, right? 2 goes into both of these. They also both have an x. So our greatest common factor would actually be 2x. So that would be the first one, and then we just divide each of these by 2x. So this would become 3x, and then minus 1, right? This just equals 1. Okay, over here. This one's a little tricky because it doesn't look like there's a GCF, right? But I still have to take something out. So we learned this last week when we learned about grouping, but if there's not really anything that you can take out, you're just going to take out a positive 1 because that's all that you can do, right? There's nothing else. So if I take out a positive 1, nothing really is going to happen. It's still going to be 3x minus 1, which is what we want it to be, right? Because we need it to match up with that first one. So there we go. We've got our 2 factors here. So let's go ahead and write them out. We're going to have 3x minus 1 and then 2x plus 1. And don't forget about your GCF that you circled up there, right? This 2, that 2 has to come down with all of this. So we're going to keep the 2 on the outside, and this would be our final answer. All right, let's do another one. Okay, first step, remember, is to always see if there's a GCF. So let's think about that. Is there anything that goes into all 3 of these numbers? So if you think about that for a second, you should be able to figure it out. And if it helps, just start dividing these numbers by stuff, seeing if they have anything in common. Maybe make a list of factors if you need to. But the greatest common factor here is 3. So 3 goes into all 3 of those. So let's pull out the 3. So if I divide all of these by 3, what do we have left? So this would become 5y squared. And then 18 divided by 3 is 6. So this would become negative 6y. And 24 divided by 3 is 8. So minus 8. Okay, and just like the previous example, we have a trinomial and a is bigger than 1. So we're going to go ahead and do this like we did in the last video. So we're going to multiply 5 times negative 8. Which gives us negative 40. And then let's start making our list. So factors of 40, 1 times 40, 2 times 20, 4 times 10, 5 times 8. Do you see anything that would give us a negative 6? We gotta get to negative 6. And it looks like it would be the 4 and the 10, right? If you keep the 4 positive and you make the 10 negative, that would add up to negative 6. So let's go ahead and split the middle. We're going to split it into positive 4y and negative 10y, and then we'll bring down the rest of this. Okay, and now we just have to factor by grouping. I'm going to go ahead and circle my 3. I want to make sure I don't forget about that 3. So we're going to go ahead and factor by grouping here. And let's see, what can I take out of the first set? It looks like the only thing I could take out is a y, because there's no greatest common factor for the coefficients. So we're going to take out a y, which means if I divide each of these by y, in the first term I would have 5y left over, and then in the second term I would just have the 4, so plus 4. All right, in the next set, well, the first one's negative, so I definitely have to make sure I take out negative. So it's going to be negative, and then let's see, what goes into both of these? Well, it looks like 2 goes into both of those. So it would be negative 2, and then if I divide each of these by negative 2, the first term is going to become positive 5y, and the second term is going to become positive 4. And there we go, we're basically done. We just have to write it all out. So our first factor is 5y plus 4, and then we have the y minus 2, and we also have that factor of 3 that's got to go on the outside here. And there we go, that one would be all done. That's completely factored. Okay, let's do this example. Same thing, look for a greatest common factor first. So it looks like it's going to be 2, right? 2 goes into all 3 of those. So let's pull out the 2 and see what we got left. So if I divide everything by 2, the first term is going to become 16w squared, and then minus 8w plus 1. There we go. And then let's factor the trinomial that we have left over here. So let's go ahead and multiply 16 times 1. That's just 16. And then factors of 16. So 1 times 16, 2 times 8, 4 times 4. Now we're trying to get to a negative 8 in the middle. So do you see factors that would get us to negative 8? And it looks like it would be 4 and 4, right? But you are going to have to make both of these negative, because I need them to add up to negative 8, and I need them to multiply to positive 16. So we would have to make both of them negative. So let's go ahead and split this up. This would become negative 4w and negative 4w. And then we'll just bring down the positive 1, bring down the 16w squared, and then we'll go from there. So let's see. Let's factor by grouping. Oh, I want to circle my greatest common factor too, right? I can't forget about that. So, and if you want to just keep bringing it down, you know, you can. If you want to keep bringing it down on the outside just to remind yourself, you can definitely do that. Let's go ahead and factor this by grouping. So we'll group these two together. And what goes into both of these? Looks like 4w. 4w can go into both of those. So if I divide by 4w, the first term is going to become 4w. And then the second term is going to become minus 1. And then over here, there's not really a greatest common factor except the negative. I have to take out the negative, right? So we're going to take out the negative 1. And then if you divide by negative 1, it's just going to flip the signs of both of these. So this will become positive 4w. This will become minus 1. And in this case, this one's a little different than the other examples. In this case, the factors are actually the same thing. So 4w minus 1, and then 4w minus 1. And don't forget about the 2, right? We got to bring that 2 down. Now the best way to write this, I don't know if you remember from previous videos, but if you have factors like this and they're exactly the same thing, the best way to write this would actually be 4w minus 1 squared, because you have 2 of the same factor. So we would just simplify that by writing it as squared. And then you do have to bring down the 2, so we would still have the 2 on the outside. So this would be the best way to write that one. All right, so I have more example to talk about, and this is if the leading coefficient is negative. So this is something we already know, but remember, anytime that leading coefficient, which just means that first term, if it's a negative, you have to take out the negative, even if you don't have any other factors to take out. So if there's no greatest common factor, you still have to take out the negative 1. So that's what we have going on here. There's no greatest common factor aside from 1, you know. There's nothing that goes into 4 and 8 and 5. So there's nothing else that we could take out. But that first term is negative, so you do need to take out the negative. So I'm going to take out -1. You don't have to write the 1. Typically they don't write the 1. It's just kind of standard way to write it. So I'm not going to write the 1. But just keep in mind, I'm actually taking out a -1. So we're going to put the negative on the outside. And then we're going to divide each of these by -1, which would really just flip all the symbols, right? So this negative 4x squared, that's just going to become a positive 4x squared. This negative 8x, that's just going to become a positive 8x. And the positive 5 is going to become a -5. So that's all we did so far. We just took the negative out, and then we rewrote the trinomial. And now we have to factor this trinomial. So we're going to go ahead and factor this trinomial the way that we were doing before. So we will multiply the 4 times the -5. That's -20. And then let's list out our factors here. So 1 times 20, 2 times 10, 4 times 5. And we're trying to get to a positive 8, right? So positive 8, it looks like we're going to have to use 2 and 10. Make the 2 negative, keep the 10 positive. So let's go ahead and split these up. -2x, positive 10x, and then bring down the rest of this. You don't want to forget about this negative, right? We do have to bring that down at the end. So let's go ahead and factor by grouping here. So if I group these two and these two, let's see what our greatest common factors are. So in the first set, it looks like I can take out 2x, and then let's see what I would have left over. If I divide the first term by 2x, I end up with 2x, and then the last term, well, that's just going to give me a -1. And then let's see what we can take out for the second set. Greatest common factor there would be 5, right? We can take out a positive 5, and then if I divide both of these by 5, I'm going to be left with 2x minus 1, which is what we want, right? Because it matches this one. And now we're done. We've got our factors. So we have 2x minus 1, and then 2x plus 5. And we also have that negative that we took out in the beginning. So that negative has to stay on the outside there. And that's it. That would be completely factored. So just keep that in mind. Anytime you have a negative, you have to take it out if it's in the front. Okay, so that is how you factor trinomials when there's a GCF. All right, see you next time.